Welcome to this comprehensive course on multimodal RAG. This course is designed to help you master the generation of AI systems where text, visuals, and videos come together seamlessly. So we will start by exploring what multimodal RAG is, diving into its core concept and real-world applications. From there, we will break down the underlying architecture, uncovering the essential components and interactions that power these multimodal systems. Next, we will guide you through effective ways to prepare and pre-process data, ensuring videos, images, and text are optimized for retrieval. We will also get hands-on with vector database and learn how multimodal embedding retrieval works. Then, we will explore advanced techniques for retrieving and synthesizing information from images and videos, enhancing your ability to build truly intelligent applications. By the end of this course, you will have a practical understanding of multimodal RAG, empowering you to create AI solutions that bridge multiple types seamlessly. So let's get started. So first, we will see what is RAG. RAG, Retrieval-Augmented Generation, is an AI framework that combines retrieval mechanism with generative model to produce more accurate and contextually relevant output. In a typical RAG setup, a retrieval component searches for relevant information from a large corpus of documents or data, which a generative model that uses to produce responses or summaries. So this combination allows for more informed and context-aware generation, improving the output quality. So now let's see what is multimodal RAG. So multimodal RAG extends this concept by incorporating multiple data modalities such as text, images, and tables. The ability to process and integrate information from distinct area sources makes multimodal RAG system highly versatile and applicable to various use cases. So these systems can understand and generate outputs considering the full spectrum of available information, leading to more comprehensive and accurate results. So now let's move forward and see what are the components of multimodal RAG system. So the first one is data ingestion and processing. So the system needs to handle various data types, extracting and pre-processing information from text, tables, and images. The second is retrieval mechanism. So this component searches for relevant data from a corpus or database using embeddings and other search algorithms to find the most pertinent information. Then third is generative model. So a large language model LLM like GPT-4o, Gemini Vision Pro generates summaries, answers, or other outputs based on the retrieved information. Then comes integration and output. So the retrieved data and generative outputs are integrated to provide a coherent and contextually appropriate response. So now let's move forward and see some multimodal RAG implementation where we can implement RAG. So the implementation revolves around a multimodal retrieval generation system that processes and summarizes data from PDF file including text, images, tables, and other things. So the multimodal class is designed to handle multiple data modalities. It integrates with the large language model LLM for vision and text processing and provides various utilities functions to summarize and process. So there are different data types like PDF extraction. So to extract and classify distinct types of content from PDF files, facilitating efficient data processing and summarizing. So the file processing module is to dissect a PDF document into its constituent element, including text tables and images to facilitate further analysis and processing. So its key features encompasses taking a PDF file path and extracting various elements using chunking strategy, wherein the document is divided into manageable chunks based on headings or titles. So the next comes summarization. The implementation includes distinct summarization processes for text, tables, and images, each tailored to its data type. Text summarization returns the input text as summaries, serving as a direct pass-through. So table summarization employs a templated prompt to query with GPT-4o, which summarizes the tables, and this processes allow for batch processing with a set concurrency limit to manage multiple tables efficiently. Next comes storing data in Milvus. So preparation for data insertion involves pre-processing and converting summarized elements into suitable formats. So each component is encapsulated in a document object with relevant metadata. And the next is storing tabular data in PostgreSQL. So adding table data to PostgreSQL involves converting the table into a data frame, mapping its data types to SQL compatible types, and generating an SQL query to create the tables in the database. So the data is then inserted row by row and the transaction is committed to ensure persistence. So synchronizing with PostgreSQL entails pushing the table data to the database, retrieving it and displaying it in a data frame format. And the last is generating responses. So when handling queries, the system employs a tailored workflow depending on whether the query relates to text, tables, or images. For text-related queries, it begins by searching for semantically matching text summaries around stored as document in Milward. So the relevant text documents are fetched based on their similarity to the query, and the results are displayed using Streamlit's text display function. So the implementation of multimodal RAG system efficiently processes and responds to diverse queries related to text, tables, and images from the PDF document. So the system ensures accurate and contextually relevant responses by leveraging advanced search capabilities using multimodal RAG. So now let's move forward and understand architecture of multimodal RAG. So welcome to this module on multimodal RAG architecture. So this diagram represents a data pipeline for AI-driven knowledge retrieval, showing how structured and unstructured data is processed and embedded and stored in a vector database, okay, for efficient retrieval. So first, data extraction. Here you can see data. So the pipeline starts with the raw data sources, which include text, tables, and images. Text means document, articles, reports, or any written content. And tables is like structured tabular data such as spreadsheet or database. And images is like visual data including scanned documents, pictures, or diagrams. So these data sources are then chunked or summarized to make them easier to process and search. Second one is data processing and embedding, these two. So see, once extracted, so data undergoes two possible processing routes. First is like start embedding, which is this, and second is multimodal embedding. So what is this standard embedding? So here the extracted text, tables, and images are converted into summarized or chunked version for embeddings, right? And raw version of tables and images are also retained for reference. And the processed embeddings are stored in the vector store. Okay, here you can see the vector store. And in multimodal embedding, so this approach processes data across multiple formats simultaneously. Instead of treating text, tables, and images separately, it creates a multimodal embedding which allow AI models to retrieve context-rich information that combines text, tables, and images. Okay. So these multimodal embeddings are then stored in the vector store. So here is the vector store. So what are the key features and benefits? So first one is semantic search and AI retrieval. So by embedding data into vector representation, see, users can retrieve relevant content using semantic search instead of relying on exact keyword match, right? For example, like instead of searching for revenue report Q3, you could ask show me financial trends in Q3 and retrieve relevant data. And the second one is multimodal data integration. So this approach enables AI model to interpret and relate multiple data types like text, tables, image in one go, or you can say together, right? And the third is like you can optimize for large scale applications, which will allow for fast AI driven search and retrieval. It's useful in chatbots, recommendation engines, knowledge graph, and enterprise search solutions, right? And multimodal RAG have real world use cases as well, like you can use in enterprise knowledge management, AI powered search engine, legal and compliance research, healthcare and medical AI, like that. So this pipeline represent a cutting edge approach to AI powered data retrieval. So by leveraging multimodal embedding and vector storage, businesses can enhance search capabilities, improve their AI model performance, and enable smart decision making across various industries. So now let's jump into the demo part. So in this demo part, we will see how to integrate Gradio, a multimodal RAG Retrieval-Augmented Generation pipeline and video processing capabilities to build an AI-powered chatbot that can interact with videos and images, right? So I will write here, from Gradio underscore utilist import get demo. Okay, so what is this Gradio underscore utilist? Okay, so here if you will see this Gradio utils.py, so here is the full code of that particular thing which we are importing. So what is this? So here, let me give you a quick overview of this particular code. So we are importing various libraries like Gradio, LansDB, LangChain, MoviePy, PIL, and other things. And we are processing videos by extracting frames and generating transcripts as well. And we are using a vector store LansDB for retrieval and embeds data with a bridge tower embeddings we are doing here. You can see bridge tower embeddings, right? And I guess what are the vector stores we have discussed in this module, right? And we will implement a conversational AI assistant that can integrate retrieval based responses with the language model. And we will build a Gradio powered web interface where users can input their queries and interact with the chatbot, okay, using particular video and the image as well as. So right, so let's break it down. Okay, so here in this section we are importing Gradio, which creates a web-based UI for AI-powered chatbot interaction. This pathlib handles file operation and OS handles file operations, and this enum data classes and typing, which used to define structured objects in Python, right? And prediction guard utilize, here you can see prediction guard. It will provide AI based inference method, and this we have discussed about this bridge tower embeddings, which will embed text, images, and structured data into a vector store. This multimodal LangChain, this basically it is a vector database used for the retrieval, right? And you can see here LVLM, and we will discuss these things separately in modules as well. Okay, don't worry. So this LVM-LM is large vision language model, which enables text to image and image to text understanding. And there is one MoviePy. Yeah, here you can see MoviePy is here, which handles video processing basically. Fine. And here, if you'll see here, this is for the error handling errors, a generic error message to handle potential failures in the processing pipeline. If any error will come, so this particular message will pop up. Okay. So here we are doing video processing, extracting a video segment from a particular video, right? So here we will extract a short clip from the video at a given timestamp, and we will save this processed video in this splitted videos, and we are using MoviePy to clip this segment and ensure audio synchronization. Fine. And moving on, this is the RAG chain setup. Right, what are the functionality of this? So it will initialize LansDB as a vector store to store AI embeddings, and it will use bridge tower embeddings, right? This bridge tower embeddings to embed text, images, and videos, and it will implement a retriever for searching the most relevant video frames. Okay, so we will write like spacewalk, okay, because we will import space station video basically. So if I will write the text spacewalk, so it will give me that particular frames or videos of some seconds where from the video where the actual person is doing spacewalk, right? And we will integrate a language model LVLM to generate responses, already told you, right? So here we are defining prompt processing, right? So it is basically a AI chatbot. So here we are defining prompt processing. So it will retrieve the most relevant video segment from the vector store. It will extract transcript frame and metadata. See, it will in the demo part, it will give me the 2 points, 2 section it will give me. One, the text, particular text. If I will say what are astronaut talking about, okay, so it will give me that, and a particular video of that segment. Okay, particular video segment from the vector store it will give me, and it will extract transcript frame and metadata, and it will return formatted data for the further AI processing, right? So if we'll go below these things, so the AI chatbot instance managing conversation history. So the functionality of this is to store conversation history, video data, and AI retrieval result. Okay, so it will keep tracks of images, caption, and extracted video segments. Fine. If we'll go below this thing, it will create a Gradio based web UI with a video player for reviewing extracted video segment, a chatbot for conversational AI response, a drop-down menu for predefined questions, and clear and submit button to user interaction. So here you can see length of a current conversation should be 2, means 2 lines only. The first response message of current conversation should be none. Fine. So yeah, so basically this particular scripts build a multimodal AI chatbot that extracts frames and transcripts from the video, stores embeddings in a vector database, retrieves relevant video content based on user query, generate AI responses using a language model which is LVLM. It will provide a Gradio powered UI for users to interact with videos and chatbot. So this system is particularly ideal for AI driven video search, content retrieval and interactive learning. So let's not waste time and let's build the particular chatbot. Okay, so now I hope you guys know what is Gradio utils. Okay, so now let's run it. Let's see utils. Sorry, spelling mistake is there. Yeah, so now I will write here debug false. Okay, you can change this to true if you want to debug something here, and I will write here demo equals to get underscore demo. Okay, then I will write here demo dot launch because I want to launch. Okay, server name equals to 0.0.0.0 demo server port 9999 and debug equals to debug. Fine. So what is this get demo? Okay, if you go. So here we are returning the demo. Fine. This. So we are calling this function, you can say here, right? So let me run it. So it will take time, I guess. So yeah, it's running on local URL. This is this to create a public. So now my app will launch. So this is my app using Gradio UI. Okay, so here what you can see, you can just enter the query. You can see here build with Gradio. So there are some predefined queries. Okay, so astronaut spacewalk. Okay, first you will do this, just if you do send. So now here the video will come, and this is multimodal RAG chatbot. Okay, so it's taking time. Yeah, so here you can see the image shows as the astronaut wearing a white spacesuit, okay, standing on a spacecraft and performing a spacewalk. And now if you will play this, so you can see the spacewalk. So this is not, so it is the full video. So from that full video, it is just giving me this video segment where a person is doing a spacewalk, right? Okay, if you don't want your chatbot to remind everything, you can just do clear history, right? And if you'll see here, what is the name of one of the astronauts? Okay, just send it. So now it will come here, the astronaut. Okay, what I can do, I can just clear history. Okay, the history is cleared, and now I can write this and send it. Okay, so what is the name of the one of the astronaut is named Robert Benkin. Okay, if you will play here, so see the name is coming, okay, from that video, right? So now again clear history. If you want to write something from your own, you can write as well. Okay, and you can upload your YouTube video as well. And what does the astronaut say? We'll do send. So here, if I will play, so first, what does an astronaut say? So the astronaut says 2 months. The view is always amazing. I didn't think I would do another spacewalk, and to now have a chance to this. right? So here you can see, okay, audio is not available as of now, but this is the right thing, right? So this is how you can create an interactive demo. So this is how you can learn about multimodal RAG system architecture, right? So now let's move forward and see in next module how to pre-process videos for multimodal RAG. So in this module, we will learn how to pre-process videos for multimodal RAG. So first of all, let's change the title name to Multimodal RAG Video Preprocessing. Okay, it's multimodal. Fine. So let's start doing setup. So for setup, we have to import some major library. Okay, so I will write here from pathlib import path. Okay, then import OS, then from OS import path as OSP. Fine. Then import JSON, then import seed, then import WebVTT. So I will explain you one by one what are these things. Then I will write import, then from file.editor video file clip. Fine. Then I will write from PIL import image. Cool. Then the last one I will write import base 64. Okay, so now let's run it. I will be small, then L will be small. Yeah, fine. Yeah, now it's working. So what is this pathlib.path? So it will provide an object-oriented approach to handle file system path. Okay, and it is used for creating, managing, and you can say verifying the file paths efficiently, right? And what is this OS? So it will interact with the operating system to perform file and directory operations. Okay, it helps us manage files, directories, and environment variables, right? What is this OS.path? In the short form, you can say OSP, right? So this is nothing but some module of this OS that provides function to manipulate the path, the file path actually. And it is very useful for joining, normalizing, and extracting paths for file path. Okay. And what is this JSON? So JSON is a module for encoding and decoding JSON data, and it is used for, you can say, storing, reading, writing metadata in a structured format. Okay. And what is this CV2? This is nothing but OpenCV, an open source computer vision library and image processing library, you can say. And it is used for extracting frames from videos and processing images. This is a library for handling web video text track, you can say .vtt subtitles, and it is used for extracting and processing subtitles from the video files. Basically, it gives the subtitles. And what is this Whisper? Whisper is an AI based automatic speech recognition model from OpenAI, right? So it will convert speech from video into text for transcription and analysis. And what is this movie.py editor video file clip? So it's a module for video editing and manipulation. It is used for trimming, extracting audio, and processing video files, right? And what is this PIL image? So PIL is Pillow, a library for image processing and manipulation. It enables resizing, savings, and modifying images efficiently. And what is this base 64? This is a module for encoding and decoding base 64 data used to convert images and videos into a text-based format for easy storage and transfer. So basically, these setups ensure efficient video pre-processing for multimodal RAG, enabling AI models to process and retrieve relevant video, audio, and image-based content. Okay, and we will be performing this video thing. So yeah, so now let's move forward and download some video corpuses, right? So I will be using YouTube video. Okay, so you can choose yours and you can put the link, right? So let me write it quickly. So this is how we are downloading the video. And so basically Jupyter Notebook downloads a video, YouTube video. This is the YouTube video link and its subtitle, and save it to the specific this directory, and then we will display the path and transcripts content. Okay, so here you can see this download video, a function from the utils module used to download videos, YouTube videos. And this is, I already told you, get transcript.vtt. Okay, this vtt, web vtt. So this is another function from utils. So this will fetch the subtitle transcription basically of the YouTube video in .vtt format. Fine. Now let's run it. And you can download any video, or you can put any video, YouTube video link. Fine. So now I will write here print video 1 file path, then print video 1 underscore transcript file path. Okay, basically we will be printing video file path and the transcript file path, subtitle file path. Okay, let me run it. So see, this is the file path with the name welcome back to planet Earth, and caption.vtt is the transcription path, right? So now what we will do, I will write here head n15, then video 1 underscore transcript file path. Fine. And I will run it. So you will be wondering what is this. So this uses a shell command head n15 to display the first 15 lines of the transcript file, and this video transcript file path dynamically substitute the actual file path. Okay. So now I will write from URL library dot request URL retrieve. So now I have added video to URL, so which will download a video from a Amazon S3 URL, and it will save it to local directory and ensure the necessary folder exists. Okay, you can see here video 2 directory. Okay, video 2 name is toddler and playground. So this URL retrieve, this is a function from Python URL library dot request module, which will download a file from a given URL and save it locally basically. And so these are the URL for the second video, you can say, and this URL is split into 2 lines for the readability, right? And these are the specific folder where I want to save my video or store my video, you can say, right? And this path video to directory, it will .mkdir, it will create the directory if it doesn't exist. What suppose this directory doesn't exist, so this will create the directory, and ensures that all intermediate directories are created. If missing, this parent equals to true, right? This parent equals to true, and exist okay true. So this will prevent the errors if the directory already exists, right? And this URL retrieve video to URL OSP destination path. It will download the file from video to URL and save it to the specified directory and nothing. And this 0 will ensure that only the file path of the downloaded video is stored in this video file to file path, right? So moving forward, let's import helper function. I hope everyone knows what are the helper functions. In the previous module, I have showed you already the utils file. Import. There are two times is utils. Yeah. Then I will add from utils import maintain aspect ratio resize. Okay, so now let me run it. Cannot import name. Okay, now it's working. So why I am doing this? So basically the purpose is to convert timestamps into seconds or milliseconds. So timestamp basically is like 00 colon 2 colon 15. Okay, 2 minute 15. So I want to change into seconds or milliseconds, and likely used for video segment extraction where timestamps need to be processed. And what is this maintain ratio resize? So it ensures images are resized without distortion, and likely used for video frame processing or thumbnail generation in multimodal RAG system. Fine. So now let me write one function which will extract and save frames and metadata as well. It will receive an input and a video and its transcript. Okay. So now let me explain you. So this is the function basically. So the purpose of this function is to extract frames from a video and links them to the textual metadata from its transcript. So this path to video is for the video file, and this path to transcript is for the subtitle, which is which will come in .vtt format. And this path to save extracted frames, it is the directory where the extracted frames will be saved, and the path to save metadata is like directory where the metadata file will be stored. Fine. So yeah, so this metadata is an empty list that will store metadata dictionaries for each extracted frame. And here we are basically loading video using CV2 OpenCV, and we are loading transcript using web.vtt. Fine. So I don't want to repeat again and again. So this will load the subtitle file, and now the iteration part will come. So here you can see for IDX transcript in enumerate trans, it will iterate over each transcript entry in the subtitle file. So each entry represents a specific segment of the video with the start time, end time, and the text caption. Okay, and the text caption. So this is start time, end time, and mid time. This is start time, end time, and mid time. Will calculate the middle timestamp. It will convert start and end times into millisecond using S2R, this str2 time function. Right. So later on we will extract frame at midpoint. Okay, we will clean the transcript by removing new line character /n, and we will extract a frame from the position, right? So later on we will resize and save the extracted frame. Okay, here I have wrote if success. So yeah, it will save the resized frame as a JPEG image, JPEG image, and it will create later on and storing metadata. Okay, so you can see here. So it will store the frame path, basically frame file path, and it will save transcript text. It will store segment ID. It will store video path. It will store timestamp of extracted frame. Right. This is nothing. This is for handling errors. If frame extraction fails, it will print an error message, which is this: error cannot extract. And at the end, yeah, we are saving the all metadata as a JSON file into this part to save metadata.json. So let me run it. Yeah, successfully run. So here the output path to save extracted frames and their metadata, and here we are creating these output folders if not exist, and here we are calling the function to extract frames and the metadata. Fine. So yeah, here I will write metadata column 4. Okay, it's metadatas. Okay, just remember, see this metadatas. Yeah. So you can see we have the timestamp, we have the video path, we have the video segment, right? Everything is here. Yeah. So now let's pre-process the video corpus without available transcript. For that I have to write. So basically this process usually take a long time, around 1 to 2 minutes. Okay, it depends again uh, to your system. For better performance, depend on how much memory your system has. So you might want to try larger whisper models that are large V2. Okay, so yeah, it's done. Audio came, and now I will write model equals to whisper dot load underscore model, which is small. Okay, and then I will write options equals to dictionary, then task equals to translate and then best of equals to 1, then language equals to English. Okay, EN means English. Then I will write results equals to model dot transcribe path to extracted path of audio file. Then I will write options. Okay, so what is this? Model equals to whisper load model. So this will load the small version of OpenAI's whisper model. And whisper is an AI based automatic speech recognition model, ASR model. And whisper is an AI based automatic speech recognition, ASR model. So here you can see this task equals to translate. This will transcribe the audio while translating non-English speech to English. And this best of equals to 1. So it will use one transcription attempt, which is basically the higher values improve accuracy but increase processing time, right? And this results equals to model dot transcribe. It will run the whisper model on the extracted audio and generate the transcript into the English, right? So now let me write the code which will save the generated transcript in VTT format. So now you can see here it will convert the transcript into VTT format based on the basically used for video subtitle, and it will also ensure proper timestamp formatting for synchronization, and it creates a path to save the generated subtitle file basically, and it will save the transcript file, okay, in write mode here. That's why I wrote W. And yeah, so now it will display first few lines of the generated scripts, right? Here you can see as I look back, so these are the generated, you know, subtitles you can say, and these are the timestamps. Fine. So now I will define the LVLM. Okay, what is LVLM? Large Vision Language Model to generate a caption for an image extracted from a particular video. See, I will write some prompt. So first it will extract the image of that particular, uh, it will extract the image from a video, and then it will generate a caption for that image. Okay, so I will show you LVLM. I will write here. I will just write here. Can you describe the image? Fine. And I will run it. Yeah. So it sets a textual prompt that will be given to the LVLM model. So the model will analyze the image and generate a caption. So now I will load the extracted frames. Okay. So for that I will write path frame equals to OSP dot join this video one directory. And then I will write here rectangle frame underscore 5 dot jpg. Then I will write frame equals to image dot open, and I will write path to frame, right? Then I will write frame. So it defines the path to the fifth extracted frame. That's why I wrote frame underscore 5. Then it will opens the image using PIL image module, and the frame is displayed in Jupyter Notebook when this cell is executed. So basically we are using Jupyter Notebook. Fine. Now let me run it. Okay, so this is the frame. So this is the image extracted from the video using LVLM, right? So now I will ask what is this image, okay? Or basically I have already written, can you describe the image? I will call that. Fine. So I will write from utils import LVLM inference comma encode image. Then I will write image equals to encode image path to frame. Okay. Then I will write caption equals to LVLM parents LVLM from comma image. Then I will write print the caption. Fine. Now let me run it. Okay, LVLM prompt is not defined. Okay. It's not defined. You can see why this error is coming, because I have only wrote here LVLM, not LVLM prompt. So now again run it, and again run it. Okay, then again run it. So now it won't give me error. So basically it described the image. So the image features a space shuttle with a person inside floating in the air. Okay, see the person floating in the air. The shuttle is positioned in the middle of the scene, and the person appears to working on the spacecraft. The person is appearing on. So this is the power of RAG, multimodal RAG. So now what I will do, I will extract frames and metadata for videos. Okay, And same, I will write the function like this. Okay, this function, one more. So here I have wrote a function to extract frames and metadata for videos using LVLM inference. Okay, so yeah, so here I have wrote same, this is the same function basically. So this will metadata will store the metadata of all the extracted frames, and it will load the video using CV2, and later on it will get the frames. Okay, and after that it will iterate all the frames using this, and it will save frames to JPEG, and later on it will prepare the metadata. Okay, and it will save all the metadata for the extracted frame, and later on you can see this. Okay, so what is this? So this will save the path of extracted frames and metadata and their transcript, and it will create these output folders if not existing, and it will call the functions to extract frames and the metadata. Fine, and here is the generated output, you can see here. Okay, so this image features a young boy walking on a playground, as you can see, holding a water bottle. See, holding a water bottle, this, and in his hand he is wearing a blue shirt and a pair. So this is how you can process videos for multimodal RAG, and you can extract the particular image you want. Okay, and you can ask for to describe the particular image, and you can do whatever you want to do. Okay, so this is it, and in the next module we will see what are the vector stores in the multimodal RAG. So in this module we will talk about multimodal retrieval from vector store. So basically, what are the vector stores in RAG? So vector stores, okay, let me first just change the name. Vector store. So yeah, let's talk about vector stores first. So what are the vector stores? So vector stores plays a crucial role in RAG by enabling efficient storage and retrieval of high dimensional embeddings for text, images, and multimodal data. So in RAG, a retriever fetches a relevant information from a vector store, and a generator like LLM uses it to generate informed responses. In modules 2, we have already learned about vector store, but again, so let's go quickly through how vector stores work in RAG. So vector stores, the first step is embedding generation. Embedding generation. So embedding generation means like data which is in the form of text, image, video frames is converted into dense vector representation using models like OpenAI, BERT, or Clip. And the second comes storage. So storage is like, so these embeddings along with metadata are stored in a vector database. And then third, it comes retrieval. So retrieval is like when a query is made, the vector store finds semantically similar embedding using techniques like k nearest neighbors, which is KNN, or approximate nearest neighbor, which is ANN. And the last come augmenting LLMs. So this is the retrieved result provided context to the generative model and improving accuracy and relevance in responses. So why vector stores matter? So the first one is it is very fast similarity search for real-time AI application. And the second thing is it enhances LLMs by grounding responses with the retrieved facts. The third is it is very scalable and multimodal, works with text, images, and video. Okay, so vector stores are very critical in modern AI application like chatbots, search engines, and recommendation systems, and many other things. Right? So now let's start first by doing our setup. In setup, basically we will import some major libraries. So I will write here from mm_rag. So this is multimodal, basically means dot embeddings dot bridge tower embeddings, import. I'll write here bridge tower embedding. I will explain you why I'm writing this and what are the use for this. So I will write from m_rag dot vector stores dot multimodal LangChain import multimodal LangChain. Fine. Then I will write import LangChain. Then I will write import JSON. Then I will write import OS. Then I will write from PIL import image. Then I will write from utils import JSON file. Then I will write from utils import display retrieved results. Okay, so let me run it first. Check there is no error, I guess. Yeah, no error. So this code imports necessary libraries and modules for embedding, vector storage, JSON handling, and image processing in multimodal RAG pipeline. Yeah, so first of all, what is this bridge tower embeddings? Okay, so this is a model that converts images into text into vector embeddings, and it is used for retrieval based AI models that is searching relevant images text in a vector database. And the second is this from rag vector store multimodal LangChain. So basically multimodal LangChain is a vector database used for storing and retrieving multimodal embeddings, supports image, text, and structured data embedding. And LangChain is the underlying vector database library that stores embeddings efficiently, used for the fast similarity search and retrieval, right? And what is this JSON and OS? So JSON is basically handles reading and writing JSON files in a structured format, that is metadata and embeddings it handles. And OS, everyone knows, it provides functions for file handling and directory operations, right? And this PAIL is for handling, loading, processing, and displaying image. It is very useful for resizing images before embedding generation. And this from utils import load JSON data is to load and parse JSON metadata, and display retrieved result means it will display the retrieved search result in a structured format. Okay, this thing it will retrieve search result in a structured format and likely used for visualizing search result from the vector database. Fine. So purpose of this is for embedding images and text for AI powered retrieval, for storing embeddings and processes and retrieves multimodal search results. So now let's move forward and let's set up LangChain vector store. Okay, for that I have to write here. So we are setting LangChain vector store. So here I will write LangChain host file equals to. So I have to save here. I will write shared underscore data LangChain. Okay. Then I will declare the table name. So I will write table name equals to what to give. I can write test underscore table. Okay. So now I will initialize vector stores. So for that I will write db equals to lens db dot connect lens db underscore host file, right? So let me run it. Some spelling mistake is there, I guess. Lens db host file is not defined. Okay, some spelling mistake. Should be capital. Now it will. Yeah. So what is this? So here I have declared the host file first, right? So it will define the location of the LansDB database file, and here I am declaring the table name. The table name is test tbl table, and here I am initializing the LansDB vector store, which will connect to the LansDB file, and if the database does not exist, it will be created. Fine. So now let's move forward and let's ingest video corpus to LansDB using the LangChain, right? So here I will give the, I will prepare the data. Okay. So let me write it quickly. So this is how we can ingest video. So this is for, basically this section is for loading metadata files. So it will define the file path for metadata, which is JSON of two videos, video 1 and video 2. And it uses this load JSON file to read the metadata from JSON file into Python dictionaries. And the metadata contains extracted frame path, AI generated caption, which is transcript, and other relevant details. Okay, and this video 1 trans is the list of captions, which are transcripts from video 1, and video 1 image path, this is the list of path which are the extracted frames from video 1, and same goes for video 2, right? So let's run it. So now I will update the transcript with the contextual information. Fine. So here n equals to 7 I have written. So it defines the number of neighboring transcript entries to be included for each frame, and this will help us in providing more context when storing or retrieving video captions, you can say. And here I have written updated video 1 transcript basically. So it will iterate over each transcript entry in video 1 trans, and it will combine caption from n by 2 previous and n by 2 next. Okay, n equals to 7 already is given. And it will handle the edge cases, like if there are not enough previous transcript, it starts the index from the 0. And this will ensure that each extracted frame has more surrounding context in its transcript, right? Later on with this, we are updating metadata with new transcript, replacing the old transcript in video 1 metadata with the updated context aware transcript, right? So now I will write here to display example before and after one. So what I will do, I will write here print f, I will write transcript example okay session, then I will give here curly braces, I will write here video 1 underscore transcript 6 okay, then I will write here print, then again I will write print same as after update, right? Same slash n, then I will write here updated video 1 trans is 6 like this. Fine. Yeah, let me run it. So here it is showing a sample transcript index 6 before and after date. Okay, so it will help verify that context has been successfully added. So here you can see a transcript example before the spacewalk and to now have chance to have done. Okay, after update, listen. See, 2 months, the view is always amazing. I didn't think I would another spacewalk and to now have chance to have to do. See, after this also we have something, right? So this is how it helps us. So now let's ingest data into LangDB with multimodal embedding. Fine. For that, right. So here I'm using this bridge tower embedding, which is a model that converts the text and images into vector embeddings, and these embeddings are used for multimodal search retrieval. Okay, so here I am using this text which will combine the caption for both the video, and this image path will combine the extracted frame path, and this embedding I'm using for basically it uses bridge tower embeddings to generate vectors, and metadata will store additional details. Connection equals to db, which will connect to LangDB, and table name is like uses test underscore table as the database table, and this mode override ensures the vector store is reset before ingestion. Fine. Now let's run it. So now we will do multimodal retrieval using LangChain, right? We will create connection to a table in LangDB, then we will retrieve from LangDB vector store using LangChain. Fine. So for that, I will write here table equals to db dot open underscore table. Then I will write table underscore name. Then I will write print f. So I will write there table dot two pandas. Pandas is Python library which used for data frames, and all shape I will write here 0. Then I will write here rows in the table. Fine. Then I will end it with this. Yes. So now I will display the first 3 rows of the table. For that I have to write table dot two pandas. Okay. Then I will write here text comma image path. Okay. Then dot head. Head is used for displaying top 3 rows, and instead of head if you use tail, so it will show you last 3 rows. Okay, 3 is already written here, so yes, let me run it. So yeah, so top 3 rows are this. See, text is this and image path is this. Okay, we got everything. So now we will do retrieval from LangDB vector store using LangChain. Fine. So this will create a vector store in LangDB, and this URI will specify where the database is stored, and this embedding equals to embedder. It uses bridge tower embeddings for retrieval, and this table name specify which tables to retrieve data from. A retriever for similarity search, so it will create a retriever for similarity based searches, nothing else. And here we are querying the vector store, so it will search the LangDB vector store using the query a toddler and adult. Let me run it. Okay, see, a toddler and an adult. Okay, this is the adult. Okay, and it will retrieve the most relevant store data, which is the text and images. So text is here, image is here. Fine. And if you will do this similarity search, which is this, okay, similarity is equal to 3. So it will give you 3 similar images with this similar text. So let me run it. 1, 2, 3. Okay. And here it is considering in adult, but here I don't think so, but yeah, toddler is there. Okay, but I told you it is similar. So this is how it improves search query by retrieving multiple results and all. So let's move forward, and now let's move forward and see what are multimodal embeddings. So now let's move forward and see what are the large vision language models. So in this module, we will learn about LVLMs, or you can say we'll see how large vision language models help us in multimodal RAG systems. So first of all, let me change the title. LVLMs, large vision language models. So yeah, so what are the large vision language models? So LVLMs are AI models that processes and understand both visual and textual data. Unlike traditional LLMs, large language models that handle only text, LVLMs combine computer vision and NLP, which is natural language processing, to interpret images and videos alongside textual description. So how LLMs work? The same thing. First, multimodal embedding. LVLMs encode both text and visual inputs into shared vector space, allowing them to compare and relate different modalities. Then pre-trained vision language models, then come cross-modal learning. So there are some popular LVLMs, okay, like Clip, which is by OpenAI. It matches images with their most relevant caption, and there is Blip 2 as well, which generates and understands natural language description for images. Flamingo is there, which processes both images and text to answer queries. Then Bridge Tower is there, which we have already used and discussed before, which is very efficient multimodal model for vision language tasks. And if you will say why are LVLMs important, so the first thing, it enable multimodal search, whether it's finding image, text, or videos, whatever, and it improve AI perception, like understanding memes, charts, text, or scanned documents. Basically, LVLMs are power application like image captioning, VQA, multimodal chatbots. So yeah, LVLMs bridge the gap between vision and language, making AI more context aware and interactive. So now let's first do the setup and what to say. Just let's import some basic libraries. Okay. So like I will write here from pathlib import. I hope everyone knows this, but still I will go through quickly one by one. URL library dot request URL retrieve. Okay, then I will write from PIL import image, and from IPython dot display code display. Okay, then I will write from utils import encode image. Then again I will write from utils import first is prediction card our conversation comma I will write LVLM parents with conversation, right? Let me run it. Okay, path let import that P will be capital. Yeah. So yeah. So this setup will set the necessary imports for working with LVLMs and enabling image processing, retrieval, and multimodal inference. And this path handles the file path and directory management. And this URL retrieve downloads file from the web, basically image and models, whatever. And this image will handles loading and processing images, and this display will display the images inside Jupyter Notebook. And this utils encode image will convert an image into a base 64 encoded format for LVLM inference. And this utils import prediction guard lava. So this prediction underscore guard lava, it's likely a predefined conversation structure for LVLM based model like lava. We will use this, and this LVLM inference with conversation is used to perform inference using an LVLM model supporting contextual conversation with the images. Fine. So now let's prepare data for multimodal processing. Okay, for that I have to write here. So now here we are preparing data. Fine. And this will include file path, text description, which will be used for multimodal retrieval. So here first in URL1 we are storing the URL of an image from the Coco dataset, and this image can be downloaded and processed for the LVLM task. And later on we are defining metadata for the first image. So these are the metadata, and the link is the URL of the image, and transcript is a text description, caption of the image, or you can say alt text, sorry. And you can path to file means local file path where the image is stored. And this image to metadata, this thing is like, this is basically metadata for the second image extracted from a video frame, and the transcript is giving, I repeat, and the transcript is given and the path to file is given. Fine. So now let's import metadata for the image third. So here the same thing is happening, then same image 3 metadata like image 2. This is the transcript, this is the path to file. And here if it's like, you have to check if the image file in this particular location exists locally or not. If the file does not exist, so download the image from this image data, which is the link, and save it to the image1 metadata path to file. Okay, here the link will come, here the location will come. It will ensure required images are available before processing. Okay, so now let's run it. So now moving forward, we will use lava. Okay, so let me write as the lava. So what is basically lava? So lava is large language and vision assistant. It's an end-to-end trained large multimodal that connects a vision encoder and LLM for journal purpose, visual, and language understanding. So Lava doesn't just see images but understand them, reads the text embedded in them, and reason about their context, all while conversing with you in a way that feels almost natural. And Lava is adept at tasks like explaining a complex chart, recognizing and reading text in photos, or identifying intricate details in high resolution images. Fine. So now let's see how we can do image captioning. Let's do some use cases with chat completion with Lava. Okay, the first we will do image captioning. That is what I was trying to say. This is the for image captioning I will write. So here I have written the prompt. Please describe the image in detail. Okay, image path is this, and it will prepare the conversation, this part. And here it caption will call the completion endpoint from the prediction of the guard. Okay, let me run it. Yeah, so I will write here, it will display the caption and the image. Okay, so I will write display image dot open image path. Fine, then I will write print caption. Okay, then run. So now you can see the image came, okay, and the caption. So the image features a group of 5 men wearing blue shirt standing. So okay, yeah, see, these are the 5 men wearing blue shirt, okay, and standing together in a space shuttle. They appear to be in relaxed and comfortable environment. So this is how you can do chat completion of image captioning, right? You just provide the image, it will caption you using Lava. Fine. And now you can ask the visual cues on the images. Like, so here I have one more prompt. So okay, let me run it. So I have written what is likely going to happen next as per the image. So I will write here display image dot open path. Then I will write print answer. Okay, let me run. So yeah, so first let me show you only the image. So this is the image, and I have written the prompt what is likely to going to happen next. You can write anything. Okay, you can ask anything. So here, see, in the image, a man is performing a handstand on a skateboard at the beach. Okay, fine. It is likely that he will lose his balance and fall off the skateboard. And handstand are challenging and require a significant. So the model is predicting that after this he will fall, basically. Okay, as per the visual cues, right? So this is how you can, ask anything to your models using LVLMs, right? And here I have used the Lava, and you can use anything, and you can ask the follow-up questions and all, right? So in the next lesson, we will see how to use multimodal RAG with multimodal LangChain. So in this module, we will see how to perform multimodal RAG with multimodal LangChain. So let me first rename this multimodal RAG with multimodal LangChain. Okay, so yeah, so rename it. So let's first understand what is multimodal LangChain. Okay, so multimodal, let me write here for your So multimodal LangChain extends LangChain's capability beyond text by integrating multiple modalities like images, audio, video, and structured data into AI workflow. So this will allow Retrieval-Augmented Generation (RAG), search and inference using text, vision, and audio, plus more. So yeah, so key components of multimodal LangChain are multimodal embeddings, which will convert text, images, video, and audio into vector representation. It will models like Clip, Blip, Bridge Tower. I have already discussed. These are LVLMs or OpenAI Vision Transformer are used, and key components covers also like vector database for multimodal retrieval are there, multimodal pipelines are there, LLM plus LVLM integration is also there. There are many use cases of multimodal LangChain as well. Like you can use it in image and video search. Even you can use it in multimodal chatbot, document processing, even in healthcare and security. Why to use multimodal LangChain? So it enhances RAG application or RAG pipelines. It enables AI reasoning beyond text. It improves search and recommendations as well, right? So now let's do the setup part. First, for that, I have to write import, I will write here import LangDB. Okay, I will write here from utils import JSON file. Then I will write from mm_rag dot embeddings dot bridge tower. I hope everyone knows what is bridge tower now. Bridge tower underscore embedding import bridge tower embeddings. Fine. Then I will write here from mm_rag dot vector stores dot multimodal underscore LangDB import multimodal LangDB. Okay, then I'll write from mm_rag dot mlm dot client import prediction guard client then I will write from mm_rag dot mlm dot lvlm import lvlm, then from pil import image from LangChain underscore core dot runables import. I will write here runnable parallel, then I will write runnable pass through. I will write runnable fine. Yeah, so now let's see one by one what are these things. So I hope everyone knows what is LangDB. So LangDB is a vector database used to store and retrieve multimodal embeddings like text, image, video, and it supports the fast similarity search for RAG based AI models. And what is this importing? And this utils is like importing utility function, and here load JSON file is like it will load metadata and embedding stored in JSON format. And here this bridge tower, so this bridge tower embedding is a vision language model LVLM that convert text and images into vector embedding that is used for multimodal retrieval. And this thing multimodal LangDB is a custom LangDB wrapper for handling multimodal data, which is text plus images, and it allows storing and retrieving embeddings as well. And this thing is provides AI powered inference for multimodal RAG, and LVLM here is a model that processes image and text queries, and this PIL import image is like it handles image loading preprocessing. And this runnable parallel is it will allow running multiple components at the same time, that is image and text retrieval. This runnable pass through it passes data without modification, and this runnable lambda applies custom transformation to data, right? So now let's move forward and configure LangDB for multimodal retrieval. So first we have to declare the host file. So I will write here LangDB underscore host file equals to dot share underscore data lens db. Okay, then I have to declare the table name. Okay, then I will write table name equals to test underscore table. Fine. So this is how you can set up lens vector store. And now I will initialize the embedding model. Okay, for that I will write embedded equals to bridge tower embeddings. Fine, then let me run it. So here now we will create a retrieval. For that we have to create a LangDB vector store again. For that we have to write this, and now we have to create a retriever for the vector store and with search type similarity and search rags. Okay, so here k equals to 1 similarity, we have to run it. So now we have to invoke the user query. Okay, so let's suppose this is the user query. Okay, so this will get the first reviewed of the video segment. Okay, this will get the first retrieved video segment. Now let me run it. So using this it will retrieve or you can say get all the metadata of the retrieved video segment, and this will extract the frame of the retrieved metadata, and this will get the transcript, and this is to get the video path where the frame was extracted, and this is for the timestamp to get the timestamp where when the frame was extracted. Okay, so this is to display the things. So now let me run it. So here you can see transcript is there and the image is there, right? We have both the things. So now you will be wondering what is transcript. Okay, so if you'll go up and if you will see our query, what do the astronaut feel about their work? So the model is guessing this particular guy is speaking this, is telling this, you can say. Like as I look back on the mission that we have had here on the International Space Station, I'm proud to have been a part of much of the science activities. This is this. Okay, this is the part of extracted frame, then this is part of video and the timestamp. Fine. So now moving forward, we will do an LVLM inference module. We will initialize client and LVLM for the inference first. So I will write here client so prediction card client. Okay, then I will write LVLM parents video equals to, I will write here LVLM client equals to client. Fine, let me run it. Yeah, so here I have initialized a client as prediction guard client, and here I have initialized LVLM with a given client. Fine. So now we have to invoke LVLM inference with user query. So how we can do this? So we can write here like this, augment query template. So the transcript associated with the image is the transcript which will come, and this is previous query. So let's run it. So it will print the augmented query. So the augmented query is the transcript associated with the images. So see, the transcript associated with the images, then the transcript will come. So this is the generated prompt, you can say, or generated answer. As I look back on the mission, we have this, right? So now what I will do, I will use the augment query and retrieved part to image as the input to the LLM inference module. Okay, so now what the LLM say? Okay, so now LVLM response will come. Here see LVM. So LVLM is saying the astronauts in the image appear to be proud of their work on the International Space Station. See, they are all wearing shirt and ties, which suggest a professional. Maybe slightly it's wrong because of something. I guess it's taking its shirt. So like this. So this is the LVLM prompt response. So now we will do prompt processing module. So for that I have to define one function. So this function processes user queries and retrieved video metadata, formats the input and prepares it for the LVLM inference using LangChain runnable lambda. So yeah, so this is we are defining the function, you can say prompt processing, and later on it will extract the video frames plus transcript retrieved from the vector store using retrieved result, and the user query is the original user question, this thing. And later on using this retrieved result, it is for choosing the most relevant retrieved result, like you can say the top ranked similarity match. And here we are defining our prompt template. So yeah, the user's original query, you can say. And later on we are extracting the metadata from the retrieved result. After that we are formatting the processed output, you can say, and the last one is we are initializing a LangChain runnable lambda. Fine. Now we have to invoke prompt module with retrieved result using a user query. For that I have to write here, and later on I can write print input to LVLM. Fine, let's run it. Yeah. So the prompt, you can see the transcript associated with the image is this, and all the user query and everything is coming. So now we will define the multimodal RAG system as a chain in LangChain. Okay. For that I have to combine all the modules into the chain and to create multimodal RAG system. Right. So yeah. So again we will invoke the RAG system with a query like we used to do before as well. So see what do the astronaut feel about their work. Okay, so the user query will come. So now if I will check with the another query, so what it should give. See what is the name of one of the astronauts. See, one of the astronaut name is Robert Benken, right? So yeah, our RAG response, multimodal RAG response is coming fine, right? So now we will check the particular image. So now only text is coming. So we need an image as well. So for that I have to write this multimodal RAG chain with retrieved image. Okay. So now I will try with the query 2. What is the query 2? What is the name of the astronaut? I guess this is the query 2 only. Done it. Images. Okay, image came. So now we can now extract the final text response with the path of the extracted frame. So see, the path is everything is came. So now let's run it. So you can see the name is coming Robert Benken. So here only the text was coming. So here this is how you can use it for to retrieving frame of the particular image, right? So like this you can ask anything to your multimodal RAG using multimodal LangChain. Okay, like we have, let's suppose we have one more query. Okay, and let me run it. So the query is describe the image of an astronaut's spacewalk with an amazing view of the earth from the space behind. So if you'll see, spacewalk is coming. Okay, so now let's slightly change the query, because if you will see, the earth is not visible. So for that you can just write one more query. Okay, at that. So what I will do, I will write here query 6 equals to, yeah, we run it now. See, now proper spacewalk is coming and the earth is also coming. So this is how you can use multimodal RAG with multimodal LangChain, right? So congratulations on completing your introduction to multimodal RAG course. So you have taken a big step in leveraging AI or RAG to enhance your project skills. So now it's time to put your learning into action. Try integrating RAG and multimodal RAG into your projects or into your workflows and experiment with prompts to optimize project efficiency. Thank you.